thing here, and I am the first talk, is to get you up to speed on AI and generative AI. And if you've never done anything with AI, this should get you into a space where you can actually reason about it in some capacity. Then we'll take a networking break. Please get more food and drinks. And then Tim will come and show us how to do stuff in the browser with AI. He built a really cool product, actually, that he's going to show us. So with that, let me just get started. This is the Berlin AI Meetup page. Make sure I'm sharing my screen here. Am I? Am I? Do we have my screen or no? Yeah, okay, great. I was talking on the live stream. Do we have it on the live stream? No? No problem. We'll just hang up, and this is very improvised. Here, let's try this again. Screen share with room. I'll share my entire screen. Wow. Woo! You can make this a game. Okay, it's good now, probably. No? Yeah, great, excellent. Hey, live stream. That's for you. So let's go to the meetup and look at our agenda. So this is where we are, about like 8 minutes late, but never mind. We're going to talk about the state of AI in 2025. How many of you have worked with AI? And I don't mean like prompted ChatGPT. How many of you have built something with AI? Okay, great. Yeah, it's about, I'd say 40%. I want to, just for the sake of our discussion today, formally define what AI engineering is, okay? And then we'll look at some techniques that AI engineers use to solve problems, and then we'll wrap up. So let's start with AI engineering. This is a paper from a good friend of mine, Sean Wang. So anyone know this? Show me this. You've read this before? Wow, like no one. Sean, crazy. Okay, so this was published a long time ago, almost 2 years ago, and it talks about what AI engineer as a title even means. And really, the cornerstone of this is this diagram. You've got this side of the spectrum, which is data and research constrained. This is where you find like machine learning research and machine learning engineering, data science. You have an API down the middle, and this is where the AI engineer sits, right? This is in front of the API. So I think people will get mad at me probably, but the most crude example of an AI engineer is somebody who can make a network request to an API and get a response and then use that to solve a problem. You interface with it. You don't make the LLM, you interface with the LLM. Is that clear? I see some of you nodding. And then, after the AI engineer, you become the next level is a full stack engineer, meaning you combine various parts of the stack, back end, front end, etc. AI is one of those specialties, okay? This is the definition we're going to be working with because this is the generally accepted consensus in the industry. The CTO of Vercel, anyone use Vercel in the room? Yeah, okay. CTO of Vercel, Malte Ubel, a Berliner actually, also agrees with this. In fact, here, this is probably all the evidence you need that this is the accepted definition. This is a quote from Andrej Karpathy. He says, in numbers, there's probably going to be significantly more AI engineers than there are machine learning engineers. And so he's making this distinction. One can be quite successful in this role. This is the kicker. You see, without ever training anything. So AI engineering is not really training models and lambda calculus and all of this. It's the application of AI. It's not the creation of AI. Is that track? Excellent. So now, if you've had some imposter syndrome already, you should have less, because if you can, how many of you can make a network request like with JavaScript, curl, wget? Everybody, welcome. You're about to be an AI engineer. Do fetch to api.openai.whatever. That's one of the things that makes an AI engineer. Next, something that you should not miss and hopefully have not missed is RAG, a very powerful technique in AI engineering. How many of you are familiar with RAG? Okay, yeah, everybody, more or less. Does anyone feel comfortable to come explain it up here on stage? No? Okay, I will do this just for the people in the room who aren't yet familiar with RAG. RAG is a technique to extend the knowledge of an AI model. But it's interesting because a lot of people think, oh, this means you create a new model. You do not. You just enhance the context. With RAG, which stands for, by the way, Retrieval-Augmented Generation. Okay, and if you know English, retrieval, you get data from somewhere, and you augment, you change the generated output. Retrieval-Augmented Generation. So it's really just adding context to your prompt to change the output. I think instead of talking about it, I will just show you how RAG works. And I'm going to show you how RAG works using a tool that we create at DataStax, which is called LangFlow. It's open source. I'm not here to sell you anything. In fact, we were going to have salespeople come here and they were like, nobody's going to buy anything, and they just didn't come. This is a true story. Like, Cynthia, hi, you should have come. Anyway, I'm just going to show you LangFlow, which is, if you go to langflow.new, I built this, the Langflow.new experience. And so this is the tool. It's just a big workflow, just a big diagram. And this is an agent. We're not going to talk about agents yet, but I want to show you RAG. So I'm just going to delete all this stuff. Okay, and we're just going to start from a blank canvas, and we'll illustrate RAG. So let's build like a basic AI app. There's a chat input somewhere here, chat input. And how does an AI app work? You have a chat input, you have a language model. In this case, I'm going to use OpenAI, probably the most popular, right? And I'm going to get a chat output component. And these are all just components. They work in isolation. So I'll do chat output. And I will take the message from the chat input, feed it to input here. I will choose my model. I think 4.0 mini is a decent model. Let's choose 3.5. Just it's cheaper, faster. Add an API key, and that's it. And now I take the output and I'll plug it in here. This is it. This is all there is. So now if I go to the playground, you can see the playground button here. It should just do a basic like AI discussion. I'll say, hi, how are you? And I'll hit enter. And there we go. Hello, I'm just a computer program, so I don't have feelings. Wow, what a smartass. That's fine. It works. And it's the most basic AI app. But we're talking about RAG, right? For example, let me show you. I'm going to, if I want some real-time information, this is GPT 3.5. It doesn't have any new knowledge. For example, which movie won the Oscar for Best Picture in 2024, right? This is a language model. There you go. I'm sorry, but I'm unable to provide real-time information as I am an AI assistant and I don't have access to the internet. Sucks. It's useless. Now, if you ask this to ChatGPT, you're not going to have this because ChatGPT performs RAG for you. Did you know this? Like if I go to chatgpt.com, or I guess chat.com now, which movie won the Oscar for Best Picture in 2024? You can see it's searching the web. You see, it retrieved and augmented that. You saw that, right? That's RAG. But how does it do that? We'll build a model here with Langflow to understand. And again, the underlying model, GPT 3.5, does not change, okay? So we just need to add some steps. So we have our chat input. That's okay. But we need some stuff. We need context, like real-time context. So between the input and the model, we'll have a different component called a prompt. And a prompt is basically what you think. It's just it's text. It's a prompt. But our prompt will have real-time context. Okay, so we'll say, pay attention to given this context, and I will create a variable context. Answer the question. Okay, like this question. And so in the curlies, I've created a variable. And so now if I save this, I have these two inputs. So the question comes from the user, goes into the prompt input, but the context has to come from somewhere else. This is RAG. We retrieve context and put it in a prompt. Is this clear so far? It's a very powerful technique because the model itself is useless. It doesn't know like modern stuff. We need to retrieve that. In Langflow, there's a component in data called URL. And this is a URL, but it can be anything. It can be a PDF. It can be an Excel file. It can be your Gmail inbox. It can be whatever you want. And so we're going to find, I don't know, where did they post the Oscar winners? BFI Oscars 2024. This is the British Film Institute, and they published like which movies on. So I'm not going to read this. I'm just going to give this to my LLM with Langflow, and I'll paste the URL here, and I get back a message. That's the string content of the website. And this will go to context. Is that clear? So this is by the way, this is what they mean by prompt engineering. I'm literally like engineering a prompt here for RAG. So I'm retrieving some real-time context. I'm constructing this beautiful prompt, right? And now I go to the playground and look, everything's the same. I will literally just ask the question again, copy and paste. And so now it's going to get that context from the website and fail me. That's so bad. You're laughing at me. I feel like should be supportive. Anyway, so here, the movie Oppenheimer, this is what, yeah, thank you, yeah. So, hey, Langflow team, if you're watching that, it's because they cached you get it, you're engineers. So, but we could do even more. We like, which movie had movie had the best cinematography. I have no idea where this is going, but it's retrieving this context. Okay, I guess even Oppenheimer. What was the worst movie? I don't know. Oppenheimer. Uh, okay, it's subjective to you can't. That's great. Best music, and so you could. I guess I made my point. You can chat with like. I guess Oppenheimer just. What movie was not Oppenheimer that once? Imagine making such a good movie that just wins every award. Okay, there. The Boy and the Heron was not Oppenheimer, and one. You see what I mean? GPT 3.5 doesn't know any of this, right? We did that. Is that clear? That is so powerful. Now you see why RAG is such a powerful technique. This was a movie thing, but hey, we could do even better here. Let's take a step up and consider. And this, I don't know if this is going to work. I'm improvising. I don't know if you can tell, but we're doing RAG with a website. What if instead of a URL, we got a file, right? And this file was a PDF, a complicated science paper that nobody can read or understand. So let's go. I actually had this handily open. Anyone read this paper? Yes? No? This guy's like, he's not sure. I read half, but I zoned out. We will cite this paper in a minute, but this is a paper that people like to say they read but never read. He says true, yeah. So I actually did read this paper, and I'm going to download it here, and we'll give it through Langflow to. Okay, so I just downloaded it, and I'm going to Langflow here, and I will upload this. Whoa, my screen is pink, but I guess I can see. Like literally, you should check this out. I don't know if you can see this. See that? It's like completely destroyed, but I will see if I can get it from here. Downloads, agents. What new white paper? This one. I'm literally just watching my screen. And I'll upload it, and it's going to upload right here. Okay, so I upload, and so now you see I get back data, but I need to turn this into text. So I'll do message to string. I think this is the component. Message to, nope, it's data to message, right? And so I'm going to so it gets you JSON from the PDF, and I'm going to convert this data to text, and I'm going to give this text as context. So I'm chatting with this PDF now instead of the internet. And if I go to the playground, I'll just open a new chat, and I'll say, tell me about this paper. I don't know if this is going to work, to be fair, but we'll see. This will probably take a little bit more time, but here, the paper discusses the foundational building blocks of generative AI agents. Whoa, crazy. And it's 3.5 turbo, so it's really fast. You can also say, who are the authors of this, just to confirm, and notice I say this, I don't give any more context. The authors are Julia Wiesinger, Patrick Marlowe, and Vladimir Ruskovich. And if we go look, just to confirm, yeah, perfect, look at that. And so chat with your PDFs, chat with your Excel, chat with whatever. LLMs are fundamentally awesome at taking unstructured data and giving you new data, either structured or unstructured. Is that clear? Super, super useful. So this is RAG, extremely powerful technique. GPT 3.5 is a cheap model. Nowadays, it costs nothing. So if you combine RAG with the right prompt engineering, you can really drive some powerful business outcomes, okay? There's one thing that you need to consider, and this part of our agenda, is what if I don't want to use OpenAI? I don't trust them. I work in Germany and GDPR or whatever. What's that? DeepSeek. DeepSeek, I love this. But also some people don't trust China. But it's open source. I think that's what you meant. You can do this. So let's explore this. So instead of OpenAI, this is the power of Langflow. Because now that I've built this flow, this API button gives me an HTTP endpoint. And every time you call this HTTP web endpoint from any front end, any command line, anything, it will run exactly this and give you the output deterministically. Incredible. But what if I don't trust OpenAI? Well, I can just delete that component. Everything else in my RAG flow is still there. And I'll go find Olama. Anyone use Olama? Yeah, great. Olama is a way to run open source models on your hardware, in your data center. You don't have to send the data anywhere else. And so I have my prompt just straight here, input, and I get the message here. The problem is it's self-hosted. I don't know if I have Llama running locally. Oh, Llama. What's the port? Is it this? There's no 4 in Llama, I think. 11434. I was wrong. So we'll check if I'm running it. 11434. I'm not. Do I have it installed? I do have it installed. Okay, I'll just quick demo of Ollama. It's important because this is how you own your data. Fabien is here. Bonjour. Sorry, friend of mine. We work together at 3 different companies. Wild. So I have to install this. Okay. And this is very important, I think, because often you just want to run something locally. Okay, cool. Ollama is running. It's totally running, but it's running on localhost, right? And langflow.new is in the internet. So how do we bridge this? Any ideas? ngrok. Exactly. There's another thing called localhost.now or something like that.
Pingy is also.
How do you spell that?
Ping and Y at the end, I guess.
Pingy? Oh, that's
Maybe
this one.
it's not the one.
Okay.
But this was really easy, even easier than ngrok.
It's this one, localhost.run. I think this is the easiest. For those, if you want to expose something running locally, just do this. SSH-R port to your local port and maybe a password. So I'm just going to do this. And Ollama is on 11434. Fun fact, this is llama in LeetSpeak. So let's go do that. Localhost.run. I did not plan to show you localhost.run today, but here we are. I think it's important. You're interested in this, right? I'm not wasting your time. Okay. If I am, just, hey, thanks. If I am wasting your time, just say, shut up. So let's do this. I want to run, what's happening? SSH-R port 80 on the web to localhost 11434. And maybe some no key at localhost. Host localhost.run. Okay. Yes. There we go. Do not scan that QR code. Don't do it. But I want to now go to Langflow here, and the base URL is this port 11434. And I will refresh, right? And whoa, I'm not stressed at all about that. Okay, cool. It's fine. I expected.
Yeah, without the code.
Wow. You see, these are good people. They're helping me. They're not laughing at me. Anyway, no, the problem is I need to expose Ollama itself. So I think it's like there's an environment variable. Okay, yeah, we're not gonna spend too much time on this. I will. Yeah. Give it up for this guy, everybody. He's a real engineer. Okay, so I think we need this one. This is the variable. And okay, and we say Ollama serve. They are super. They're like locally running LLMs. Wow. Reload. Okay, well, does that link even do anything? Does it say Ollama is running? Okay, access is denied. This is crazy. There's one more. Yeah, no proxy. Somewhere here, there's a setting. Jeez. We'll do a hack night after this. Okay. We'll figure it out. But anyway, the point I'm trying to make was with Langflow, you can just swap out the model just like this if you want. And again, you can expose it. Also, to be fair, thanks. Also, this is pity applause, and you know it. I don't know. So the Langflow itself is open source, and this is of course langflow.new. I think it's very important to mention langflow.new is not supposed to be used like this. Okay, you're not supposed to save anything to langflow.new because this is accessible to everybody on the internet. Langflow is an open source project. You can run it on the same machine as Ollama with Docker Compose, right, or something like that. That's the way you're supposed to do it. Okay, so it's by design. This is actually not working. Final thing I'll tell you is, so we've covered AI engineering as a profession, right? We've covered RAG, which is a very powerful technique. The final thing you need to know in 2025 is agents. Okay, it's the outcome of literally this paper from Google, where they define agents. And I'll finish with this. We'll do a quick networking break, talk, exchange ideas, build stuff, and we'll do questions also. And then we'll continue with the night with Tim's talk. But this is important. What is an agent? I'm not going to read this out for you. This is a diagram. I prefer pictures to text most of the time. This is what an agent is. This diagram is from Google's paper published in October of 2024. And an agent is something that receives a user's query and is a runtime. You're familiar with a runtime? Yeah? A browser is a JavaScript runtime. Node.js is a system JavaScript runtime. Um, it receives a query, and then the agent runtime has three parts: a language model, obviously, to generate and understand language; tools, which are nothing more than functions to call; and an orchestration layer that's responsible for modeling thought. Like, for example, you ask a language model, hey, can you convert today's exchange rate, 100 euros to 100 currency? Tell me.
Rupees.
Rupees. He has watched my video. Euros to rupees. The LLM can't do that because it doesn't have access to today. Its knowledge was cut off in like October 2023, right? GP3. So it doesn't know today. So the orchestration layer will understand, hey, I don't have this. So now I need to use a tool, which is to browse the web. And so the tool, so let's contrast traditional RAG with agent-driven RAG. This is important. So as you can see, this is an agent, but we had another Langflow instance somewhere here, right? Did I delete it? Where was my thing? This one. So this is traditional RAG, right? We have a chat input, we read some data, and we constructed a prompt. Agent RAG is not, we don't do any of this stuff. We just say, here's a tool, use it when you want. And there's a word in English for that. There's a word in English for like knowing when you need a tool and choosing the right tool. What's the word? Agency. Agency. If you tell me to multiply like 18 prime numbers, I will use my agency and be like, I'm going to get a calculator, right? And LLMs have, that's why they call agents. They use agency, okay? So with that, if you go to langflow.new, you can do this right now if you have a laptop. Langflow.new will drop you straight into an agent flow. So this is an agent flow. Let's walk through an agent flow. This is the centerpiece of the agent flow. So you have a model AI provider. It can be anything you want. We choose OpenAI by default because it's just the most popular. Choose a model. I will choose a cheap one. Give an API key. We give you one for free on langflow.new. Just use it, abuse it if you want. I think there's a spend limit. If not, we'll find out. And so you have your agent, and you see this cyan thing. These are tools, and if you click on this on the left, you can see all the different tools you can use. So there's DuckDuckGo, there's Bing, there's Exa, there's absolutely bananas. There's also MCP, which we will talk about at another time. So you can connect all these tools. So what tools do we have? We have a URL tool, which can go browse the internet. We have a calculator, it's just a tool. LLMs really suck at math. I don't know if you know this, so we need an external tool for that. And that's it, we just have two tools. So let's look at this. So I'm gonna go to the playground and ask that, based on today's exchange rate, convert 200 whatever euros to, what's the Armenian currency? I don't even know. Dram, cool, Armenian dram, right? And so this, look at this, it's an agent, it's executing some tools, get the current date, evaluate the expression. There you go, it literally, and you can see its tool use process. So it got the date and it called this URL, api.exchangerate API. It did this by thinking and using agency. Linda, hello. And so it did the math and it told me at the end, after 3 seconds, the exchange rate for euro to Armenian dram is this much. And so converting this much to Armenian dram is this much. Incredible. It did RAG. Is that clear? It went to the internet, checked the exchange rate. It did all that with agency. So this is how agents work fundamentally. And this is new RAG. This is agentic RAG, right? And that's the topic of 2025, really. There's also topics of, as of today, I believe, one of the labs trained their first diffusion-based language model, which is insane if you're into machine learning. We won't talk about that. Really, the most important thing for you, if you're an aspiring AI engineer, is to master RAG and master agents, and then you're pretty much good. There's a whole section on vector databases, because for the Oscar thing, we did the RAG, that web page was not very big, right? You can't do that with the entire HTML specification. That's a 25 megabyte document, okay? And so at some point you need to break that into chunks of text and store it somewhere. This is where you use a vector database, and it will then search the vector database for small relevant chunks and use that as context. Again, agents can do this. So if I go, for example, to, let's see, vector stores, AstraDB, we make this. It's the world's most scalable vector database. Literally, Apple, Netflix, Uber, name any like billion-dollar company, they're using Apache Cassandra, which is AstraDB, okay? And so this thing, AstraDB, has tool mode. And if I turn on tool mode, I can take this and just add it as a tool. And now the LLM will exercise agency and just like search my database. Incredible, okay? So let's recap a little bit. I'll leave that there with you. I think I've given you enough to chew on while you also chew on pizza. So we'll wrap it there. I just want to go back to the agenda and make sure I covered all of this, which I did. So we're going to now take a networking break. And then in about 15, 20 minutes, we'll pick it up with Tim, who's going to talk about running AI with the browser. Absolutely incredible. I'll take any questions before. I saw some of you put hands up. Happy to take a few questions, and then we'll give you some time to network, okay? I believe you had a question.
Yeah, but you can already answer that.
Wow.
My question was about like because you showed that there's one file only.
Mm-hmm.
Basically, it's augmented generation, but there is not really the keynote. But then you
Yeah,
possibility to have a vector database.
correct. Yes. Yeah. Yeah, great.
You were telling about the cloud-hosted version. So when we make it, is it accessible publicly? Like you're telling that if you use the cloud-hosted version,
The cloud-hosted version of?
so
Yes.
is it public accessible?
No. So Langflow.new, his question for the live stream is if you use the cloud-hosted version of Langflow, is it just open to everybody? The answer is no. Langflow.new is a sandbox, right? It's just like you should go there, you prove your concept, you do something. In fact, here, let me show you. This is the typical expected usage of Langflow.new. And again, there's a strong warning here, like don't add long-lived API keys because we want you to come here and play, like really play, like talk to the agent, have a good time. And then when you want to use it in production, usually by exposing over an API, you click the API button and we're like, hey, go to DataStax and use it properly. So you can actually download the flow as a JSON and import it in our production cloud offering, and that's of course very heavily authenticated, and you decide, right, if you want it public or not. Yeah, I believe you, Misha, question.
Yeah. So the more I'm interested in the information from the rack, from my personal rack, the smaller can be the model, right? Because like I don't need as much like information in the model.
Exactly. Exactly.
Can I use a 3D or a 1D model and be fine?
Yes. No, this is a very good question. For the live stream, he's asking if he needs a large model. So there's models that are very, so for example, DeepSeek R1, the biggest version of DeepSeek R1 is 671 billion parameters. And if you don't know what a parameter is, it's like, we actually have a sound desk over there where you can adjust like volume of different channels, parameters are like that. They just like adjust probabilities to get the outcome you want. And if you picture like a soundboard with like 671 billion knobs, that's what that means. These models are very large because they have a lot of context and training data. His question was, do I actually need that for my personal project? The answer is you don't. In fact, here, let me show you my website, tej.as. I have a search feature. So I have a podcast. It's very in-depth, like really, really in-depth, 2-hour episodes. People are like, I don't have time to listen to this. So I built this for them, where you can just ask about like hosting your own LLM, and it will, with a language model, perform RAG and tell you like, hey, here's where we talked about this in the podcast. And if you click on the timestamp, you literally just go to like the place where the hosting mechanism. We're talking about hosting mechanisms, right? How do you host your LLM? So thanks. That's RAG, but I'm not using some huge model there because the model doesn't know any of this. The model was not trained on this. And so good observation, Misha. I'm using a fine tune, a variant, a fork of a model called Mistral 7B, which has 7 billion parameters. And again, for contrast, GPT-4 has 600 billion. Yeah, so 600 billion. And you can also imagine the cost savings is literally like 1% of GPT-4. So, and that's again self-hosted. It's a fork question.
What do you take for the embeddings?
What do I take for the embeddings? I use OpenAI. OpenAI has a model called Embedding 003 Large. Yeah, it's cheap. It costs absolutely nothing. And I think about embeddings, for those of you who aren't familiar with embeddings, it's a specialized machine learning model. It's a language model, but not a large language model. And it doesn't generate language. It's a model that takes words in English or any language, like dog, cat, ostrich, sandwich, whatever, and turns them into numbers that mean something. Yeah. And then you can compare the closeness between numbers. Yeah, you know, like 100 is closer to like 99 than 1 billion. Yeah, so that's how you find stuff in space. And these models, they just associate like numbers with words, okay, based on the semantics. They're very cheap to run. And so one issue you can have with these models is the number of dimensions you embed data in. It's better to have fewer than more. That's been our experience. So usually 1024 dimensions is a good ballpark. If you go in the 3000s, you're probably going to get lost because it's just too many different buckets in which you can embed things. Any more questions or yes?
Actually fine-tuning Llama for automatically extract metadata from research software.
Wow.
Recently, I have been thinking about using agents. Why not using agents to extract metadata? But I haven't seen this case of actually using agents to extract something, but rather they use something called RAG.
Yeah.
Just extracting the data from your database, for example, like vector database.
Yeah.
Getting out from GitHub or GitLab and then structuring it.
You can though. You just have to write code. This is the cool thing with RAG, right? You just like read the file. Like retrieval in RAG is just retrieving stuff. It's basic I/O. And
But how efficient it is to accurate to read something like a structured format. Like
yeah.
When I tried this agents, I was not able to succeed with extracting the fields I need.
Mm.
It was hallucinating.
Yeah.
So that's why I started fine-tuning some data set, custom data set.
That's a good approach. In fact, this is a great topic. Well done. That is the right approach based on everything I know. Smart guy. What's your name? Santosh. He's very smart. Go tell him. That's good because like a big question is, do we fine tune a model or do we perform RAG? You're fine tuning a model is like adding more layers, more parameters to the model. So say you have Mistral 7B, 7 billion parameters. You can take that as a base and give it more information. Yeah, feed it, train it on more text. Then the question is, okay, should we change the model and have our own forks and fine-tuned models, or do we perform RAG? 9 out of 10 times, RAG is better because it's way less computationally expensive. Training a model, even fine-tuning, is not easy because you have this loop of like training data and then you test the output, you do evaluations, and it's usually not going to be good depending on the quality of your data. So it's a difficult loop. You need expensive GPUs. It's just not fun. I believe me, I've fine-tuned my own models. So you want to avoid it unless you have his problem, which is he wants specific structured output. He wants it in a specific schema, in a specific format. And he says, I want objects with this specific output. And that's language. He literally just wants like opinionated JSON, right? And so the decision of RAG versus fine tuning, I hope you're taking notes, is very important. I'm not being sarcastic. The distinction between RAG and fine tuning is you fine tune when you want specific or new language because it's a language model. If it's about the information and not the language, then you do RAG. Yeah. But if it's about new language, then you fine tune. Cool. Question. I think that was the last question. Let's take a break. Listen. There's way too much food and drinks. I need you to bring your best appetite. Okay. We'll be back in about 15 minutes. Please grab some, and we'll see you soon. Thanks.